Good morning, student. So today we are just starting a new topic, that is gravitation, immediately after the completion of electrostatics. It is because that the two topics, gravitation and electrostatics, there is a complete analogy between them. Near about all the concepts which you had studied in electrostatic, they are derived from the concept in what? A gravitation. So there is an analogy. It is better whenever you are preparing for NEET or JEE, you must prepare these two topics at a time. So it is quite easy to understand the basic concept. Now, it is our common experience that whenever an object is released from certain height, say for example, a plane is released, what happens to the plane? You can observe it. That plane, it gets attracted towards the planet Earth. Any material object, whenever they are released, it may be raindrops. What happens to raindrops? They will fall, they get attracted towards the Earth. Any material object which has a definite mass, they get attracted by the planet Earth. So it was, have you heard the name of Galileo? So Galileo, who is an Italian physicist, he is the first person who observed that before Galileo, everyone knows that the material object, they get attracted by the planet Earth. But Galileo was the first person who made a statement that all the material object, they get attracted towards the Earth with a constant acceleration. With a constant acceleration. What is the meaning of this statement? Material objects, they get attracted towards the Earth with constant acceleration, whatever may be the mass of that object. So in order to demonstrate the statement made by Galileo, he moved on to the Leaning Tower of Pisa in Italy, and from the top of Leaning Tower of Pisa, from the top of that leaning tower, tower is leaning, bended. So from the top of Leaning Tower of Pisa, he released the two material objects of different masses, maybe, not exactly. So mass of one of the object, it may be 100 kg, and the mass of another object, it may be a 10 gram. So it is your expectation that when the two objects, one of mass 100 kg and other of mass what? 10 gram, when they are released from the top of Leaning Tower of Pisa, what is your expectation? All of you were thinking that an object of mass 100 kg must reach the Earth earlier as compared to that of what? A body of mass 10 gram. But remember, this is not the case. The people surrounding to that Leaning Tower of Pisa, everyone has just observed that both the object, they are of what? Such a different masses, both the object, they will reach the surface of Earth at a time. So Galileo was correct that all the material object, whatever may be their masses, they must get attracted towards the Earth with a constant acceleration. With a constant acceleration. Now remember, have you heard the name of Aryabhatta? Have you heard the name of Aryabhatta? Now as far as Aryabhatta is concerned, who is Aryabhatta? No doubt he is Indian, because he had studied the motion of planet like Earth, Sun and that of Moon. So he is an Indian astronomer. In order to study the motion of planet, one must need the knowledge of what? Knowledge of numbers. So he is a mathematician. So Aryabhatta, who is Indian astronomer, famous Indian astronomer, because he had studied the motion of planet, that's why the first satellite of India has given a name Aryabhatta. So Aryabhatta, who is a great Indian astronomer, great Indian mathematician, 500 years after the death of Christ in 500 AD, because Aryabhatta born in 476 and died in 550 AD. It means in 500 AD, an Indian astronomer or mathematician Aryabhatta, he had written his famous book known as Aryabhatiya. In a book, Aryabhatiya, he made the conclusion regarding whatever studies made by him on the planetary motion. He made the three conclusions, and those conclusions, they are very important. The first conclusion made by Aryabhatta in his book Aryabhatiya is that our planet Earth revolves around it what? Earth revolves around, or Earth revolves about its own axis. Earth revolves about its own axis. Means he had a clear-cut idea regarding the spinning motion of Earth. This is the first conclusion made by Aryabhatta. The second conclusion is that Earth revolves in a circular orbit. Earth revolves in circular orbit around the Sun. Earth revolves in a circular orbit around the Sun. And the third and the most important conclusion, that Moon revolves in a circular orbit around the Earth. See, what an interesting conclusion made by Aryabhatta 500 AD, in 500 AD, when no such sources are available for calculation. So he made the three conclusions that Earth will spin about its own axis, Earth revolves around the Sun, Moon will revolve in a circular orbit around the Earth. Exactly after 1000 years, a pair of scientists named Tycho Brahe along with Johnny Kepler, these two people, they work together. Actually, most of the work regarding the planetary motion is concerned. The observation of the planetary motion, tremendous observation of planetary motion were made by what? Tycho Brahe. Tons of observations are there. So that huge data regarding the observation of planetary motion, it was made by Tycho Brahe. But John Kepler is intelligent person. He analyzed that tons of data, huge data regarding the planetary motion, meticulously, having sitting for hours together, and at last he concluded, after studying, after analyzing the data related with what? The planetary motion, John Kepler, he concluded his conclusion regarding the planetary motion in the form of laws, and he had given the three famous laws known as Kepler's laws of planetary motion. Wherefrom Kepler's had made the announcement of three laws of planetary motion? Just analyzing the data which is what? Which is related with the planetary motion made by, most of the observations were made by Tycho Brahe, few observations were made by John Kepler, but he analyzed them and he concluded from the data, and those conclusions were the three laws. And he made the announcement. Also, he had proved that all the planets in the universe, they must obey those three laws. Every planet will obey Kepler's laws of planetary motion. Why planet has to obey the Kepler's laws of planetary motion? He is unable to explain why all the planets they are obeying the three laws. But it was a Newton. You know very well, famous physician. It was a Newton who had given the correct explanation that why every planet they will obey Kepler's laws of planetary motion. He said that the gravitational force or gravitation is that phenomena which is responsible for every planet to continue its motion in its orbit around the sun. Means in absence of gravitational force, in absence of gravitation, planets do not continue to move in their orbit around the sun. It means what? As far as the gravitation is concerned, it is only due to gravitation, dispersed mass, they get pulleys. Gravitation, it is only due to gravitation that gravitation compels. See here what I am saying, gravitation compels dispersed mass to pulleys. Gravitation compels a dispersed mass to get what? Pulleys. Means any massive object that exists, it is only due to what? Gravitation. Means in absence of gravitation, we cannot have the existence of our planet Earth or existence of planet Moon. Means what? If we are having the different masses and in absence of gravitation, these particles they remains dispersed. But as soon as gravitational force will experienced by each of them, they come close to each other and thereby they are forming what? A massive object. In other words, you can say that the existence of planet Earth is made from what? The different massive particles which are initially dispersed and later on due to gravitation they coalesce and form a massive object like an Earth. So all the massive or macroscopic objects in the universe or in the cosmos, they are just having their physical existence only due to the existence of gravitational force, or every mass, every object having a definite mass, they will experiences what? They will experiences a gravitational force. So what we can conclude? That every massive object means it may be a point particle, it may be what? A heavenly body. Every massive object in the universe will experiences a gravitational force. They will experiences what? Gravitational force. So one by one, regarding the gravitational force, what are the properties of gravitational force? A massive object, every massive object, they will experiences a gravitational force. They will experiences what? A gravitational force. Now regarding the gravitational force, what you can say? Gravitational force is gravitational force. It is what? It is a mutual force of attraction Gravitational force is what? Mutual force of attraction that exists between any two objects. Mutual force of attraction between what? Any two objects. Why the gravitational force of attraction will exist between two objects? It is only due to what? Only due to that the two objects, they are massive. It means gravitational force of attraction will arises only due to the virtue of their masses. There exists a gravitational force of attraction between any two objects, due to what? Due to the reason that the two objects, they are massive, means they are having a definite mass. They are having what? A definite mass. Now remember, as far as the two objects are concerned, suppose we are having the two objects of masses m1 and m2. Between any two material objects, there exists a gravitational force of attraction, means two objects of different masses, same masses, whatever it may be, they will attract each other. So gravitational force is force of attraction. Mutual means first object will attract the second object will also attract the first object. Why this gravitational force will exist? Because the two objects, they are having what? They are having definite mass. Now as far as the gravitational force is concerned, the range of gravitational force of attraction is infinite. Means you know very well that between the heavenly bodies, that is planets, distance of separation is very, very large. And still, as we know that heavenly bodies, they get attracted with each other with a gravitational force. Means this gravitational force is having what? Infinite range. Range of gravitational force is what? Infinite. Also remember that this gravitational force is very weak force as compared, if we compare the gravitational force with any of the fundamental force. For example, a strong nuclear force. This gravitational force is what? 10 raised to power minus 39 times the strong nuclear force. So remember that regarding the gravitational force, that every massive object will experiences a gravitational force. Second thing, this gravitational force is what? This gravitational force is mutual force of attraction between any two objects due to their masses only. This gravitational force of attraction, it will act along the line joining the given two object. Gravitational force will act along the line joining the given two object. So that's why gravitational force is a central force, because it is acting along the line joining the given two object. So gravitational force is what? A central force. As far as the range of gravitational force is concerned, it is infinite, and as far as the gravitational force is concerned, it is very, very weak. Even if we compare this gravitational force with a strong nuclear force, that gravitational force is found to be 10 raised to power minus 39 times that of what? The strong nuclear force. Now we will see Kepler's planetary laws of motion. Now we will see Kepler's planetary laws of motion. So before just studying Kepler's 3 planetary laws of motion, actually just by analyzing the data, tremendous data is made available regarding the planetary motion. Observations of planetary motions were made by what? Tycho Brahe. along with John Kepler. Together they are having tons of data regarding the planetary motion. But as far as Kepler is concerned, he analyzed those tons of data and concluded in the form of three laws. Out of these three laws, first two laws were given by John Kepler in 1609, and after 10 years, that is in 1619, the third law of planetary motion was given by John Kepler. So as far as Kepler is concerned, just by analyzing the data concluded regarding the motion of planet, in 1609 he had given the first two laws, that is known as law of orbit. First law is known as what? Law of orbit, and second law it is known as law of area. And after 10 years, that is in 1619, he had given the third law. He had given what? That third famous law. So before just knowing what is Kepler's law of orbit for planetary motion, let us first discuss, because as far as Kepler's law of orbit is concerned, Kepler's first law will gives you the idea regarding the orbit of a planetary motion. How is the shape? What is the geometrical shape of orbit along which planets are revolving around the sun? So we must study one of the geometrical figure. You know, you are having idea regarding the geometrical figure of circle. You know the equation for circle, you know the equation for straight line. So let us study what is this ellipse is. So ellipse is a geometrical figure. Ellipse is what? It is a geometrical figure. So to know what is ellipse, see here, A and B, we are having two drawing pins. So on a drawing board, we are having a drawing paper, and over that drawing paper, let the two drawing pins, they are fixed at position A and that of B. Measure the distance AB between the two drawing pins, and that distance is found to be, suppose, small d. So what we had done? We had taken the two drawing pins, and those two drawing pins, they are fixed on a drawing paper at position A and B, which are at a distance d apart. Now let us take a thread. A thread of length L greater than 2 times the distance of separation between the two drawing pins are taken. The free ends of thread, the two free ends of thread, they are tied together, have a knot, so that thread is converted into what? A loop. That loop of thread is allowed to pass over the two fixed drawing pins A and B. See here, this dark line will represent the loop of thread passing over the drawing pins A and B, and you just insert a pencil in the loop. See here, vertical line, it will represent a pencil which is inserted in the loop of thread, and that loop of thread is moved, or that pencil is moved sideways, so that the thread between A and B, it becomes taut. It becomes what? Taut. Now you start moving the pencil sideways. When you move the pencil sideways, then the lead will trace such type of geometrical path. And it is interesting to note that every point on this geometrical path, suppose P itself is a point on a geometrical path. If I measure, or if I take the sum of distance of that point from the two fixed point A and B, the sum of distance of point P from two fixed point A and B, it is found to be some constant. You can take another point Q. Again you can take the sum of distance of that point Q from the two fixed point A and B. Their sum is QA plus QB. It is same as that of distance PA plus PB, which is constant. Means locus of all the points in a plane, locus of all the points in a plane such that sum of their distances from the two fixed points, which are also called as foci, is called an ellipse. What is an ellipse? Ellipse is the locus of points in the plane such that sum of their distances from the two fixed points, say A and B, called as foci, is constant, then locus of all such point is nothing but an ellipse. Remember, if this geometrical figure which is traced by a pencil during its sideways motion by keeping that thread taut is called an ellipse. Ellipse has two axes here. This is somewhat bigger axis called as a major axis. This axis is somewhat smaller axis called as a minor axis. So now you had a clear-cut idea regarding what? The ellipse. Now we can study the first law of planetary motion, which were given by John Kepler in 1609. So according to Kepler, judged by analyzing the tremendous data, he had given the first law. And remember, first law will gives you idea regarding what is the geometrical path of a planet which is revolving around the sun. So the first law is known as law of orbit. And what does it state? That all the planets move, all the planets move in elliptical orbits. All the planet moves in elliptical orbits around the sun. All the planets move in elliptical orbits around the sun. Such that sun is at what? Sun is at one of the foci. All the planets moves in elliptical orbits around the sun with sun at one of the foci of the ellipse. Sun at one of the foci of the ellipse. Sun at one of the foci of the ellipse. Listen carefully. All the planets move in elliptical orbits around the sun. All the planets move in elliptical orbit around the sun with sun at one of the foci of the ellipse. Sun at one of the foci of the ellipse. So let us just see here. I had drawn an ellipse. Here PA, it represents what? Here this geometrical figure will represent the ellipse along which planets are revolving around the sun. So where is the location of sun? Here S will represent the position of sun. Actually S and S dash, These are what? These are the foci. These are the foci of ellipse with sun is at position S. S is what? S represent the position of sun. And planet is revolving along this elliptical orbit around the sun. Planet is revolving along the elliptical orbit around the sun. Now look at this. During the motion of planet along this elliptical orbit, when that planet is at point P, at position P, what you can say? Along the orbit of a planet, when planet is at point P, means that planet is what? Closest to the sun. So P is that position of a planet along the orbit where that planet is closest to the sun. So that point P is called perihelion. Point P is called perihelion, the closest point of a planet along its orbit around the sun. Whereas when planet is at position A, what you can say? Planet is at farthest distance from the sun. Planet is at farthest distance from the sun, and that point P is called aphelion point. Point P is called as what? Aphelion point. As far as this axis PA is concerned, this axis PA, it is called as major axis. Axis PA, it is called as what? Major axis. Because the distance between S and S dash is A, length of major axis is what? Length of major axis is 2a. So PO or OA, their length is same. PO or AO, they are called as semi-major axis, and their length, each of them, their length is equal to what? A. See here, length PA is equal to 2a, so PO equal to OA equal to A. There is one more axis of that ellipse is shown, that is MN. That axis MN, it is called as minor axis, smaller, minor axis. Minor axis. Length of MO equal to OL. MO and OL, they are called as what? Semi-minor axis. And each of length equal to B, because length of minor axis we had taken it as 2b. So if the length of minor axis is 2b, then length of MO equal to ON equal to b. That is, length of semi-minor axis is equal to b. If length of major axis is 2a, then the length of semi-major axis, that is PO equal to OA equal to what? A. PO equal to OA equal to A. So you remember the first law, Kepler's first law of planetary motion, known as law of orbit, which describes the orbit of a planet round the sun, and what it states? That all the planets move in the elliptical orbits. All the planets move in the elliptical orbit around the sun, with the sun at one of the foci of the ellipse. Here S and S dash, these are the two foci of the ellipse. Here I will say that sun is at foci S. Point P is closest to what? The sun. During the orbital motion of planet round the sun, when it reaches the position P, from where sun is closest to it. So point P, it is called as perihelion. Whereas when planet is at point A, means that planet is what? Farthest from the position of sun. So point A is called aphelion point. PA, it is major axis. MN, it is minor axis. If length of major axis is 2a, length of semi-major axis PO or OA equal to A. length of minor axis, if it is 2b, then the length of semi-minor axis, it is equal to what? b. So this is about the first law of orbit. Now see here, the second law, which is given by Kepler, it is law of areas. Now what is the statement of law of areas? See here, the line that joins the planet, with sun, the line that joins the planet with sun sweeps an equal area in equal intervals of time, The line that joins the planet with the sun sweeps equal area in equal intervals of time. The line that joins the planet with sun sweeps an equal area in equal interval of time. Let us see here. Suppose we are having a sun at position S and planet P is revolving round the sun along an elliptical orbit. This is an elliptical orbit and that planet is revolving along that elliptical orbit. Let P is any position of planet, then here a line SP, it is a line joining a planet with sun. This law states that line joining planet with sun sweeps an equal area, in equal interval of time. Sweeps an equal area in what? Equal interval of time. So actually Kepler observed the planetary motion, and what he found, that as far as planets are concerned, that planet does not revolve around the sun with uniform speed. From the tons of observation, John Kepler found that planet do not revolve with uniform speed round the sun. But what he observed, that when planet is near to the sun, the speed of planet is faster, means planet moves with faster speed when that planet is what? Near to the sun. Whereas planet moves with a lower speed when planet is farther away from the sun. For example, here A is that position of planet where planet is what? Near to the sun, and P is a position where that planet is what? Far away from the sun. So at position A, when planet is near to the sun, its speed is what? Very, very high. Whereas when planet is at further position P, means when planet is far away from sun, its speed is low. So ultimately Kepler, on the basis of this observation that planet do not move with uniform speed round the sun along the elliptical path, but planet moves with higher speed when it is nearer to the sun and moves with slower speed when it is what? Away from the sun. He had given the second law, and according to this second law of area, what it states, that the line joining the planet and the sun, it will sweep an equal area in equal interval of time. It will sweep what? An equal area in equal interval of time. For example, here if I say that planet moves from position P to P dash, or from position Q to Q dash, in a time interval delta t, means during the motion of a planet round the sun along the elliptical orbit, if I say in a short duration of time, delta t is what? Very short duration. So in a short duration of a time, if planet moves from P to P dash, or planet moves from what? Q to Q dash in the same interval of time, then see here, the line joining the planet and the sun, what is the area swept by it? It will sweep this much area. Say this area is A1, or in the same interval of time when planet is moving from what? Q to Q dash, area swept by planet is A2. Because here in a same interval of time delta t, planet is either moving from P to P dash or from what? Q to Q dash. We know very well that speed of planet here is very small. Speed of planet here is what? Large. But remember, according to law of area, these two area they must be same. Means area swept by line joining the planet and the sun. Line joining planet and sun sweeps equal area in equal interval of time. Here interval of time is same, so that's why these two areas they are same. That's why these two areas are what? Same according to law of area. Actually, you remember that this law of area is outcome of what? Law of conservation of angular momentum. Law of conservation of angular momentum. Now, what is this angular momentum? All of you know very well what is linear momentum. In your 10th standard, you came across the term linear momentum, which is a vector and it is a product of mass of an object with the velocity with which that object is moving. Direction of linear momentum is same as that of direction of what? Velocity. Means when an object of mass m is moving with velocity v, then its linear momentum p is equal to m into v bar. So for linear motion of an object, the role played by linear momentum p is equal to what? M into v bar. Now object can have rotational motion also. As far as rotational motion is concerned, remember the role played by linear momentum in linear motion is same as that of role played by angular momentum in rotational motion. So whenever object is performing rotational motion, then the momentum of that object, it is measured in terms of what? Angular momentum. P equal to m into v. Remember, the role played by mass in linear motion is same as that of role played by moment of inertia in rotational motion. The role played by linear velocity in linear motion is same as that of role played by angular velocity in rotational motion. So see here, L represent angular momentum, I is known as moment of inertia of a body, and omega is known as what? The angular velocity. Means when a body is performing rotational motion, see here, suppose we are having some body and let this body is rotating about an axis passing through point O. So let us define, if I say that this body is revolving with constant angular velocity omega. Omega is what? It is the constant angular velocity with which that body is revolving about an axis passing through point O. Let this body is made up of n discrete particles, say of masses m1, m2, m3 up to what? Mn. Body is made up of n discrete particles. It means what is summation of mi? Summation of mi means m1 plus m2 plus m3 up to mn. That is equal to total mass of body. And let these discrete particle M1, particle of mass M1 is at a distance R1, is at a perpendicular distance R1 from the axis of rotation, R2, R3, R4, Rn. So what these R1, R2, R3, R4, Rn represent? It will represent the perpendicular distance of particle of masses M1, M2, M3 from the axis of rotation. Means particle of mass M1 is at a perpendicular distance R1 from the axis of rotation. Then the moment of inertia of that rotating body about an axis passing through point O, it can be written as I equal to M1 into R1 square plus M2 into R2 square plus M3 into R3 square. In this way, Mn into Rn square. Means moment of inertia of a rotating body about an axis passing through point O, it can be written as summation of Mi into Ri square, or in general Mr square. In general what? Mr square, where similarly linear velocity and angular velocity, they are related by the relation. What is the relationship between linear velocity and angular velocity? V is equal to R omega. You know very well that when a body is performing circular motion, linear velocity of body is always what? Tangential, while angular velocity will be what? An axial velocity, omega, which is acting like this. And R, it is a position vector. So V, R and omega, they are related by the relation V is equal to what? Omega cross R. V is equal to omega cross R. And because here they are mutually perpendicular to each other, so V equal to omega cross R, or V equal to what? V equal to vector omega cross of vector R, which is equal to omega R into sine of. What is the angle between omega and R? 90. Sine 90 is 1. So that's why we will have a relation linear velocity equal to radius vector, radius multiplied by what? Angular velocity, or omega is equal to V divided by R. Now we are having two relations, that I equal to Mr square and omega equal to V by R. So the angular momentum L, which is equal to I into omega, moment of inertia into what? Angular velocity. What is moment of inertia? Mr square into what? Omega. But we know that R into omega equal to V. See here, V equal to R omega. So that can be written as M into R omega, or it is equal to MVR. L is equal to what? MVR. But also you remember that as far as linear momentum P is concerned, there is a relationship between linear momentum and angular momentum. That linear momentum, angular momentum L is equal to vector R cross of vector P, or it is equal to what? R into R cross of P, means it is RP sine of theta. If theta is equal to 90 degree, sine 90 equal to 1, therefore L is equal to RP. So angular momentum, you must remember that linear momentum P equal to mv bar, angular momentum L is equal to either mvr, or it may be L is equal to R cross of P. So we will make use of these two relationships just to understand that this law of area is actually the outcome of law of conservation of angular momentum. Now you must be clear with the concept that angular momentum, the role played by angular momentum in rotational motion is same as that of role played by linear momentum in linear motion. What is angular momentum? angular momentum, it is denoted by a letter L. L is equal to I into omega, or L is equal to mvr, or L is equal to r cross p. You remember at least these three relationship. Also you remember V is equal to r omega, that is the relationship between linear velocity and that of what? Angular velocity. So law of area, what is the law of area? Law of area, so I will just rub it. Now I want to prove that law of area is actually the outcome of law of conservation of angular momentum. Law of conservation of what? Angular momentum. Remember, law of conservation of, why I am saying that law of area is outcome of law of conservation of angular momentum? Remember that law of conservation of angular momentum is valid only for central forces. Only for what? Central forces. Now see here, between the planet and the sun, there exists a gravitational force of attraction. The gravitational force experienced by a planet due to sun, it will act along the line joining planet and that of sun. So that's why the force between planet and sun, it is a central force. Normally, how you can define the central force? A central force, suppose here we are having some object and here some fixed point O. Normally that fixed point is the origin of some coordinate system. So whenever a force acting on an object, it acts along the line joining the given object and some fixed point. Normally that fixed point is what? It is the origin of coordinate system. Such force which acts on an object along the line joining the position of object and fixed point, that force is called a central force. So here also the gravitational force experienced by a planet due to sun, it will act along the line joining the planet and that of sun. So that's why gravitational force is what? A central force. So we can think of that this law of area, it is resulted due to what? Law of conservation of angular momentum. Law of conservation of angular momentum. Now let us see here that position of planet with respect to sun, it is described by a vector r bar. What is r bar? It is r bar represent the position of planet. Position of planet from the sun. As far as the gravitational force is concerned, it will act along the line joining planet and that of sun. And as far as the momentum is concerned, we know that momentum P is equal to mv bar. So here P bar is that component of momentum which is normal to the position vector r bar. P bar is that component of P bar which is perpendicular to what? Position vector r bar. Or in other words, you can say that during the motion of an object, direction of linear velocity is what? Tangential. And because product of mass and velocity is nothing but what? Linear momentum. So remember, here P bar is that component of momentum which is the normal to what? Normal to the position vector r. And if I say that the planet moves from P to P dash in a short interval of time delta t. Delta t is very short. That planet is moving with velocity what? V bar. when planet is moving with velocity v bar in a short interval of time delta t, what is the distance travelled by planet? Distance travelled by planet is equal to v bar into delta t. Means planet may move from this point to this point. So, during the short interval of time delta t, the distance covered by planet v bar into delta t, this much is the distance covered by planet, means the line joining the given planet and the sun, it will nearly sweep an area which is equal to what? If I say delta A bar, it is the area swept by line joining the planet and sun in a short duration of time delta t. Then this area swept is actually what? It is actually the area of triangle SPP dash, SP, and you may take it as P dash, it is a triangle. What is the area of any triangle? It is equal to half of base. What is base here? Base is SP into what is height? Height is here P dash, approximately P dash. This height P dash is nothing but distance travelled by that planet in a short duration of time delta t. What is that distance travelled? Velocity multiplied by time, that is distance travelled, means height of a triangle, that is equal to half into base into height. Half into base into what? Height, that is equal to half into vector r bar cross of what is the height? It is vector v bar into delta t. So the area swept by line joining the planet and sun in a short duration of time delta t, it is a delta A bar equal to half r bar cross of v bar into delta t. Let us divide both the side by time delta t. So delta A bar divided by delta t, take this delta t to this side, so that is equal to half of vector r bar cross of vector v bar. Half of vector r bar cross of vector v bar. You know very well that if I multiply and divide this v bar by the term mass of a planet, if I say small m represent the mass of a planet, then delta A bar by delta t, delta A bar divided by delta t is equal to half of vector r bar cross of vector v bar, multiply it by m, divide it by m. But we know very well that m into v bar, what is linear momentum P equal to m into v bar. So I can replace this v bar m by linear momentum P. Therefore delta A bar divided by delta t is equal to half of vector r bar cross of vector P divided by m. Vector P divided by m. But we know that angular momentum is equal to vector r cross of vector P. So therefore delta A bar divided by delta t is equal to half of, see here, this m will be taken here 1 by 2m. What is vector r cross vector p? Vector r cross vector p is equal to what? Vector L, which is angular momentum. So into vector L. So finally we conclude that delta A bar divided by delta t equal to L bar divided by what? 2m. Remember one thing, that only for central forces this angular momentum is constant, means L bar is constant only for what? Only for the central forces, and because the gravitational force experienced by planet due to sun as it acts along the line joining sun and planet, so that's why that gravitational force is what? Central force. Means here this L is constant, so ultimately it means what? delta A bar by delta T, as L bar is constant for central force and gravitational force is central force, therefore delta A bar by delta T is constant and that is equal to L bar divided by 2m. This proves the second law, that is law of area. Remember, delta A bar by delta T, one can also talk this term as aerial velocity. Delta A bar by delta T means it is a aerial velocity. So remember, what is the law of area? Law of area, it states that the line joining the planet and the sun, see here, SP is the line joining planet P with sun S, sweeps equal area in equal interval of time. Sweeps equal area in equal interval of time. So this is the statement of law of area, and you can prove it that this law of area is actually the outcome of what? Law of conservation of angular momentum, which is applicable only for those forces which are the central forces, and as the gravitational force between planet and sun, it is a central force because it acts along the line joining the planet and that of sun, and just by defining that L is equal to I omega, or it is equal to mvr, or it is equal to r cross of p, you can prove that dA by dt is equal to L by 2m, and because L, that is angular momentum, it is constant only for the central forces, therefore this aerial velocity is constant, or area swept by the line joining planet and sun, they are equal in equal interval of time. Means when planet moves from P to P dash or from Q to Q dash in a same duration of time delta T, then the area swept in both the cases, they must be same as per this law of area. So this is all about that law of area. Now we will see what is that third law related with time period. So before just studying that third law, that is law of period, let us revise what is that law of area. What is the law of area? The line that joins a planet and the sun. The line that joins a planet and the sun sweeps equal areas, in equal intervals of time, in equal intervals of time. So remember, what is that law of area? The line that joins a planet and the sun sweeps equal areas in equal interval of time. Now the third and the most important law, after 10 years, in 1609, Kepler had given the two laws. The first law, that is law of orbit, second law, that is law of area. So in 1909 these two laws were declared, and after 10 years, that is in 1619, Kepler had given the first law in 1609, and after 10 years in 1619, he had given the third law. That law is known as law of period. Means somewhere it is related with time period of revolution of planet around the sun and the length of semi-major axis. So let us consider that here it is an ellipse, or it is a path, elliptical orbit along which planet P is revolving. This is an elliptical orbit along which this planet P is revolving round the sun. Here sun is at one of the foci of an ellipse and planet is revolving around the sun. If I say that T represent the time period of revolution of planet around the sun in an elliptical orbit and R is the length of semi-major axis. R is what? Length of semi-major axis. Then this time period of revolution of planet and semi-major axis, they are mathematically related by this relation, because as far as these laws are concerned, they were completely based on the observation, and Kepler found that the square of period of revolution of planet around the sun is found to be directly proportional to what? Cube of semi-major axis. Cube of semi-major axis. So, as far as the law of period is concerned, what you can say? That the square of time period of revolution of planet, square of time period of revolution of planet, square of time period of only t square, square of time period of revolution of planet, square of time period of revolution of planet, t square, t is time period, t square, square of time period of revolution of planet is around the sun, revolution of planet around the sun, no doubt it is around the sun, is proportional to what? Cube of semi major axis traced by semi-major axis, traced by what? Traced by semi-major axis of the ellipse, traced by planet, semi-major axis of the ellipse, traced by, who is tracing that ellipse? Traced by the planet, traced by the planet. So if I say R represent the length of semi-major axis, R is length of semi-major axis, and T represent the time period of what? Time period of revolution of planet, time period of revolution of what? Planet. Then as per the third law, that is law of planet, T square, it must be directly proportional to R cube. T square is proportional to what? R cube. So remember that third law, that is known as law of period. How you can read that law of period T square is proportional to R cube? Means here the square of time period of revolution of planet around the sun is proportional to, you may say directly proportional to, cube of what? Semi-major axis of the ellipse traced by planet around the sun, traced by planet around the sun. That is, if R is the length of semi-major axis and T is the time period, then according to law of period, that T square, it is proportional to R cube. So this is all about the three laws, that is Kepler's planetary laws of motion.